Okay, so welcome to yet another episode. I think this might be the seventh, the eighth. I know I'm numbering, but I don't remember which one is this one. So getting into what I would say the last time we will be using the software here. After this, we'll be just playing around in ArcGIS with some geoprocesses and doing gap analysis. But today we will finish by doing the landscape prioritization for the type for the set, which includes the time sets interactions, meaning that we will be using the suitability distribution for the species that we are working with for past, current, and future. In the past video, we did the same thing, but for the time lapses, but isolated. So yeah, so that's what's going to be happening today. Second. And yeah, one thing that I explained is that we need to have our file to set up the run appropriately ready, right? We've been through this. We know that we need to have the setup, the file list, where we're going to be putting the information, if we're going to have some kind of smoothing or a multiplier for the dispersal capabilities, and so on, so on. Now, for this particular run, we need to have the setup file with a couple changes, and at the same time that is going to affect the species file. If you remember, the species file is the one that has the 10 species, right? So what's basically the main difference, or the thing that we need to consider here? So while last time we just used only one time set, here we need to do the run. Well, Zonation does the run as a single set, but at the same time it's going to say, okay, so if you give me, in this case, the 1979 distribution and the 2010 distribution, so how with my suitability changes between those two? Yeah. So we need to set up that kind of interaction. Yeah. So for this, we will need to prepare our files on something like this. Apologies for the pixelated piece of art that you see here, but it is what it is. So let's imagine that each one of these black lines is the 10 species, the set of 10 species. So this is one set, this is another set. So this is 10, and this is 10, and this is 10, right? Obviously, we need to think in terms of past, present, and future, right? And as I already mentioned, Zonation will make this run as a single time and as the interactive or the transitional time. So here we need to understand who's going to interact with whom. In this case, we will take the first set of species from past interacting to the one from present. And as I am pretty sure you already deduced, we will take the one from the current to the one in the future. For this process, we do not need to run the future set as a singular thing. Now, in terms of number of like, imagine that we have this spreadsheet and we have the 10 species listed over here, because that's what we are basically doing. We need to have a spreadsheet with a list of the files, right? So how does that look? So obviously we are going to start from thinking in terms of total rows. Because we have the first and the second set for past, we are going to go from 1 to 10, it's the first set. The second set is 11, 20. Following 21 to 30, 31, 40, so on and so on. When we indicate who's going to interact with whom, is as simple as taking the first species from the first set to the first species from, in this case, the third set, or the first set from the current timeline. So that's basically what's going to happen. And our file is going to look something like this. 1 interacts with 21, and then and then 10 interacts with 30. That's in theory what we need to do. So how does that look in the actual file system? This one is the one that we used for the last video, where we have a single set. Yeah, we have the uncertainties, we have the masking, we have the rule of removal, and the mount. So what's the difference? Check this out. Boom. The difference happens here between the lines 22 and 25, right? Because here's where we are going to be indicating. Am I going to use interactions? Yes, please. So who's the interaction file? Where's the interaction file? Sorry. Okay, that is over here. And how am I going to reference my grouping models? Like, how am I going to group the information to know which set is going to interact with which set? Okay, so it's going to be on a file located here. So that's it. So let's take a look first to the file that tells us which one of each one of the species is going to interact with which one of the other species from the other set, which is basically this table that you see over here, right? You see it? Number 1 interacts with number 2, with 21, and and 10, 30, 21, 41, and 32, 50. So that's it. That's how we define how everything is going to interact. Now the grouping file, basically what we're going to do is, which is my group number 1, my group number 2, and my group number 3 that I need to consider for the interactions, and which ones I need to omit. So this is why we have here this. So this is the first group that you need to consider. Then whatever comes between the lines 11 and 20, you need to forget about that. Then this is the group number 2. Same thing over here. Please do not consider anything between 31 and 40. And finally, we need the group number 3 here. So that's it. That's how it's going to things being set up basically. And actually the list of species is going to be basically the same kind of thing, right? It's going to be this arrangement. But obviously here the only information that we have is the weighted information, the number of the species, or well, the location of the distribution and so on. Right? So for example, we can see the first species, right, for past. Line number 1, Istomaltumirani, right? So that means that in line number 11, I will find, once again in past, Istomaltumirani. So you see, it's just a matter of repetitions. In this case, it was kind of easy because it's only 10 species, so it's fine. But this was made, thankfully, with using a code in R, because we need to arrange like 94 species, so at the end it was like 400 and something lines. So anyway, so now we have all the files ready. We can go to our software, right? We already know how to load the BAT file. Basically, it's the one that we have in the folder that we want. So this is loaded already here. Ooh, there's a dog outside. There's a dog outside. Hopefully that does not interfere too much with what's going on. Anyway, so, and actually these first 3 were the ones who we already ran last time. So let's go ahead and do this guy. So everything seems okay. The species file is okay. The setup is okay. So let's go ahead and run it. It's going to take a little bit of time, so I will bring you as soon as I get a reaction. Okay, so our program is running. You see the percentage going up and how this is filling in, right? As a reminder, Zonation, what calculates is how am I going to be losing the species, and wherever I am losing the least, that's the places where it's going to prioritize the most, right? So this is our product. This is our product. I mean, I'm just, yeah, whatever, classic zonation. So basically here are all these black areas, blue areas. Those are the least important, right? We'll take a look at this in ArcGIS like more detail. Now, the other thing I wanted to show you, I think, is this. So here, Zonation prepares a couple of graphs. One, the upper right, here we see basically the trend, which is actually, it was a very steady run here, like no jumps and that kind of stuff. So we can see how we are going to be the proportion of the landscape that we want to prioritize, right? How is it going to, how much did we actually lose the species? Here we can see the same situation, but in terms of the actual species, right? Yeah, so distributions remaining mean the distributions of the species, so how much of that collective we are losing. So from 1, we have all of it, and 0, we have none. So there is like a very progressive, linear progressive kind of thing, right? The graphs in the bottom, we're not going to pay attention to it because here it's taking in consideration the cost layer. And if you remember, I mentioned that I set the cost layer and a mask layer for the same thing, so it doesn't make sense to pay attention to that. So basically, I didn't use a cost. So yeah, so sometimes it's interesting to see like where are we going, like the specific, there's some kind of jump in these graphs, because that's where we see like, oh, at this point I am losing a lot of species, right? Or I am gaining species, something like that. But here it's a very, very, very steady trend. So now, how does that look in our software on ArcGIS? Just before I show you that, this is not. So if I am correct, this is our result. So you can see it between the map that we have here. You see it? So it's the same result. Now, the only thing is that I already put a little bit of makeup, right? So it goes basically from 0 to 1. And here's what we need to be paying attention on. What do we want to do with this information? How do we plan the landscape, the territory, in terms of conservation? That is going to depend absolutely on the type of objectives. Do we want to make like protected areas, like completely isolated areas, or do we want to find areas, let's say, for example, that overlaps with agriculture or close to it, so we can implement more sustainable management and so on and so on. Maybe in future videos, or we can have a discussion. Would be nice. I'm not a very master on that kind of stuff, but maybe we can bring a little bit of good thought into it, right? For now, there are two things that we're going to do. One, we will do it here, which is the international goal for protecting areas. Meaning, there is an international interest to protect a percentage of any given territory. At this point, I think it is 10%, but a couple of years ago, it was 15%. Here, I will go ahead and restrict for 15%. That means that I want to see all the ranks, that is from 0.85 and onwards, right? Thankfully, I have done that already. And this is how it looks, right? This is the 50% of all the area of interest that I am doing over here. So what's next? We need to see what are the characteristics of these places. Does it make sense for the biology of the species that we are selecting, right? For example, right now, without knowing so much, we can see that these areas here, these are volcanoes, right? So we are talking very high altitudes and steep steep topography. So it would be, for me, immediately thinking in amphibians, that is a little bit strange. But there might be a good reason. And the difference, this area over here, which you have relatively flat lands, but also you have rivers, lakes, which kind of makes sense for this kind of group of species. So here's what we need to explore all these results. So that's where I'm going to leave the thing. Next one, we start analyzing and discussing a lot of the results that we have to see if we can have some good observations. So until the next time, bye-bye and see you soon.